Hey guys, so let's solve this system of linear and quadratic equations. All right, we're going to use elimination here because that's the only method we've learned so far. And in order to eliminate, we need to have something lined up that we can cancel out. And if we look currently, my two y's, I can cancel them out by subtraction. So I'm going to subtract this bottom equation from this top equation. Or if I wanted to flip it around, I could. And it doesn't matter. But if I picture this, uh, I have no x squared value in the top equation because it's linear. So if I subtract x squared from 0, I'm going to end up with a negative x squared. So we might want to switch and just put this linear equation on the bottom and subtract it out, and then we'd end up with a positive x squared. But I won't. I'll make it a little more challenging and show you what else we can do in case you don't recognize that. So what I'm going to do is I'm going to subtract my two equations. But what I'm going to do is I'm going to put my subtraction sign everywhere, just so I remember. All right, y minus y gives me 0. That's what I want. And now, I'm not going to subtract this negative x from x squared because I can't. They're not like terms. So I got to remember there's technically a 0x squared up here. So I'm going to do 0x squared minus x squared. So pretty much it's just going to end up being negative x squared. Now I'm going to do negative x minus negative 4x. Now I know that's kind of a lot going on there, so I'm going to write it to the side. Negative x minus negative 4x. These guys combined make a plus, so it's pretty much negative x plus 4x gives me positive 3x. All right, and then I have negative 7 minus negative 5. Again, a lot of negatives in the head. Negative 7 minus negative 5. Make a big old plus, so this is minus 2. All right, so these two, when I eliminate, I get this quadratic equation. 0 equals negative x squared plus 3x minus 2. Now, I don't like having a negative x squared. So what I can do is I can divide both sides by negative 1. You ask why? Well, then I'll have a positive x squared. And whatever I do to one side, I do to the other, it all works out. And the great thing about this is 0 divided by negative 1. I still get 0 equals, now negative x squared divided by negative 1 is still going to be x squared. 3x divided by negative 1, negative 3x. Negative 2 or minus 2 divided by negative 1 becomes positive 2. So really the only difference is everything just becomes the opposite of what it was. So now I have a quadratic equation that I think I should start by trying to solve by factoring. So are there two factors of 2 that add to get negative 3? Well, the only factors of 2 are 2 and 1. And if I add 2 and 1, I get positive 3. Oh, but also it could be negative 2 and negative 1. So 0, if I could factor this, 0 would equal, I could do x minus 2 and x minus 1. There's the factored version. So I have x minus 2 equals 0, and I have x minus 1 equals 0. I'm going to show my work. Add 2 to both sides. I get x equals 2. Do the same thing over here. I get x equals 1. Great. Now, previously we were done because we solved this quadratic equation, but I don't want to solve this quadratic equation. I want to solve this entire quadratic and linear system up here. So once I get here, I know my x values. I know it's going to be 2 comma something and 1 comma something. Those are my x values. So now I have to find my y values. Very simple. I can pick either equation, just like we did when they were both linear. We could pick either equation to plug our x into. My suggestion, pick the easier equation. Of course, you could plug 2 into x squared and then square it and then times it by 4 and subtract mine, or you could just plug it in the top linear equation. I suggest the top linear equation each time. You can then double check it in the quadratic, especially using a calculator, but I'm just going to use that top equation. All right, y equals negative x. So my first x is 2, so it's going to be negative x. It's going to be negative 2 minus 7. So y equals negative 9. So when x equals 2, my y value was negative 9. My second equation, I'm still going to use that linear. If I wanted to be fancy, sure, I could use this, the quadratic, but I'm going to use the linear to get my initial answer. It's y equals negative, or the opposite of x, so the opposite of 1, minus 7. Negative 1 minus 7 gives me negative 8. There we go. So my two solutions are 2, negative 9, and 1, negative 8. Now, to prove it, we can plug them both into the quadratic equation. All right. So if I have y equals x squared minus 4x minus 5, I'm going to take my first ordered pair. All right. This is my x. This is my y. I'm going to plug in negative 9 should equal, when I square 2, subtract 4 times 2 and take away 5. Order of operations tells me when to square my 2, get 4. In the same step, I can do 4 times 2 is 8. Take away 5. Negative 9 equals, lost my space, lost my room. Sorry, guys. 4 minus 8 is negative 4 minus 5. Negative 9 equals negative 9. It works. Now I do want to check my other ordered pair just because I have the time. Hopefully you're still watching. I'm going to plug in, you don't have to write it twice, but I am, just so I have to look up. My y value is negative 8. My x is 1. I'm going to plug them all in. So negative 8 should equal 1 squared is 1, minus 4, minus 5. Negative 8 equal 1 minus 4 is negative 3. Take away 5. Negative 8 equals negative 8. Oh my gosh, it works. So we have two solutions to this linear and quadratic system.